So today, one of the last hard problems I have not done in that were asked during past month in Google. 1944 number of visited people in a queue, n people in a queue, left to right, heights. Person can see another person to the right if everybody in between is shorter than both of them. Okay. Wasn't I solving a similar thing already? I think I was. And I'm not sure if that was the solution. I think that was some trapping grain thing. So let's say that so for it has to be a increasing sequence. So 1, 2, 3. Now when I go to this guy, how do I update answer for him? Heights are only 10 to 5 and they are unique. Okay, that might simplify it. Well, if I go to this guy, right, he can see this, and then nothing else. So basically I can see, so when I go here, okay, and when would it increase the so let's say we keep an increasing list or increasing queue, who cares? And now we keep elements that are, but we might have to call them back maybe. So only up to first larger than or larger element including. Let's say move to 1. Well, I can only remove some guys. And let's say after 3 there would be 1, 2. How would the answer change? Well, 10 would still be answer for 3. And so I think it could work potentially. I'm not sure. Let's try. So we start with the first guy. Let's say there is something in between. So there's like 5 and then 2, 1 something. So right in this case I have this, right, and then I come to this guy and I need to erase all that are larger, I guess. Maybe if I start from person with highest height. And he can for sure see the second highest person. So they can see each other. Let's go for 11, right? And now 11 sees highest to left and highest to right. And then maybe something else. Because even if for 10 I said that okay, you can see 6, 8, 11, and then I go to 6. So if it's in the queue, I remove it. You can see 8, but it's already larger, so you cannot go further. That might work. I mean, if I could lower bound. That sucks. I'm not sure, because if I go to 6, but for example here, if I would have 6 also, then I can do 6, 5, and then 6, 10. Let's say this one. Well, if you go up, so what can happen? From 10 I can either go up or down. If I go down, the answer, if I keep the increasing sequence, it can be just less, but it can also be more if I would decrease to like if there would be like 4, 6 or 6, 4, and only 6, 8 something, and then suddenly 4 is a candidate. I'm not sure, honestly. If I just keep this, there could be like 1, 2, 3, 4, 5, 6, like 1, 2, 3, 4, and then there could be 11. So now 6 can be paired with this, but 10 couldn't be paired with all that. I mean, I guess that works, and when you go to larger one, then it doesn't matter. it will be the only one in the list, so I guess it could work. What I'm thinking is still maintaining the increasing sequence. I guess, I don't know, dude. What the hell? I don't know. Auto height. In height. I'm not sure if this will be slow, to be honest. I think it will, but update the list. Well, I wanna do heights. Okay, so first I erase this. And now while not height empty and I don't know, heights are begin first, no heights, this equals while heights are begin first. Question is, I want to keep one of them in, so what we want to do is this. There is auto it1 is heights are begin and heights erase it1, right? Now what I want to do is if heights empty, then heights insert it1 break, otherwise, or heights are begin first is already smaller than height, then we just insert it back, otherwise we don't do anything. Great. Okay, and then answer I is height size. So here we keep answer, and now what we have to update? Well, I grabbed the, if we go to smaller one, we can only see something smaller than the previous one, so because it might be quite far away. there is some answers missing because I still have to. Okay, so I got some increasing sequence, and if I go to next guy, then how do I update the sequence? So I would build a sequence of this, this, and this, right? So first I erase the higher ones. What the hell? I'm not sure I will know this. Oh, there is 5 hints. Okay, at least it's solvable. Why did I pick this? I slept 5 hours and I had an exam in the morning. At least I passed. Oh my days. Why am I torturing myself, to be honest? Well, okay. How about instead of like I'm at this guy and I know I can see these two, and then okay, well I saw this guy, so I remove all the ones that are there and push this guy, and then I'm here. I guess you could suddenly see more. Well, if I go down, that's easy, right? But if I go up, so I process this, and can I put it even back? First I remove all and then I edit. But now if I see a bigger guy, then he can eat this, this, and this. I guess I have to go like this, so when I see this guy and I'm taller than him, that's okay. Whatever, there is nothing to do here. Then I'm here, and that's in queue. And then I pop from the queue nothing. I just count them. But do I really? Let's say that he can see one person, right? Then do I put this guy? Well, if I see larger, doesn't matter, he will not see it, and if I put smaller, then he will still not see it, which is nice. So I just pop this at this guy, then I'm here, size is 1, great. I'm smaller, okay, nothing happens, I put it back. I go here, 2 guys, great. And then I'm like, But the next guy will not be able to see this, so I pop it and then I have this and I'm here. But suddenly I can only see the first guy, I cannot see the second guy. And what if this would have like a height of 10 and suddenly here the height would be blah 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 and 1000. I think I'm on the right track now, but not sure how to handle that. I'm not sure because, even if I would remove everything larger than this guy, that still doesn't make sense because then suddenly, right, I remove this. But this guy can see him. This guy's 10 tall and this 11, so that kind of sucks. So this is a correct pop and this is a correct pop when I go to larger guy, but what if I go to smaller guy? Because there could be like 10, 1, 9, 1. Or like 20, 1, 15, 1, 10, 1, 5, 1. And then like 12, 1, which could mark these two. And then this guy, which could mark these two. It could just mark more and more of them, I guess so. And they would get erased whenever I get smaller one, and if I get a bigger one, then it will just enable more of them until we saw too much. So I still gotta keep the increasing sequence. Unless I really found a larger one and this will not be seen at all. So I really keep an increasing sequence. I just did not think of the update. Great, so let's go backwards. Okay, so this is my height. I mean, answer is first this, I guess. Or is it? No, not really. I want to test one thing. If I do heights, insert, I don't know, 2 minus 1, auto iterator, heights begin, and then I do heights insert 1 minus 1, and then I do auto it2 is heights and then I do sort it if it will change the value in the iterator. What is happening? So it's still 2, so it doesn't move my iterator. Okay, this might help. So let's have these heights, and now so I go backwards, and let's say I meet a thing. Heights if I it's unique, so I don't actually need this. Height continue. Otherwise, well, if I am in a larger guy, I got into a larger guy, then the answer is number of the set, the size of the set, whatever, right? So I wanna not really. I wanna iterate until I find the larger one. And then I have to delete all of them. Then the iterator. And if I delete all of, what the hell? Okay. Let's deal with a case where we have a smaller one, right? So we get a smaller one. In which case, it may not be actually is. If I get a smaller one, I can only see because it could have like some sort of unhinged so if I see a smaller one, right, then so I will actually only keep, so at the end what I want to do is while heights, not heights, and if a height begin is smaller than height, then erase heights begin, and finally heights insert height, right? So that's the end processing. And now when I get to a larger one, then I don't care, answer is if height over heights, then answer I is size of the sequence, but then I wanna erase everything. Okay, and then while not heights empty, that actually works. So, and do this. okay, in other case, if you get a smaller guy, well, it's definitely gonna be inserted. That's for sure. So I can take, let's leave it there. But now what will be the answer? Well, I get to iterator, so let's do int count is while heights is not at the end, and value of the iterator is smaller than my current height, then send plus plus and it plus plus, right? And now I want to do if, well, there is at least one guy, but if he's smaller than I guess I can skip it, I can just say one more. So this way I've moved the iterator to the first guy and I get the count, so answer I is count. And that's it, but now I have some iterator, and when I go to smaller guy I have to move the iterator backwards, and if I go to larger guy I have to move it forward. So let's first set the count. Let's set the count to 0 and iterator to this. I didn't want to submit, but okay. Oh, no editorial, that's great. You know, if I go to a smaller guy, then I can see less. But if I already am at some smaller guy, let's set the iterator to end for now. And now if I encounter a smaller one, I want to move the pointer back. That's tough. I'm having a stroke right now. It feels like my brain just stops mid-sentence. It just stops thinking. I think this is the good idea, but I just need to finish it. It's gonna be pain though with the pointers. Question is, okay, if I go down suddenly, right, then I can only see part of that, and when I go up, I could go like up here, so suddenly the pointer moves here. Or does it really? This is the start of the sequence, but then I remove it. Oh my god, that's so stupid. I need a hint. Great, I can solve it. Okay, great. Wow, best 3 hints of all time. Use a stack to keep the values of the array sorted as you iterate from end to start. Okay, I have something like that. Keep popping from the stack, but don't I have to put them back onto the stack? Because if I see a larger one and if I see okay, interesting. I mean, somewhat what I have. Stack. Let's throw this into the trash. While not the empty, and either heights the top is smaller than height or count is 0. Answer I is equal plus plus if heights stack top over heights I, so plus plus stack pop. Great. And finally okay, and then stack push I. There is no way it's simple as this. It isn't. Great. So pushed I end. Great. And then salt popped so first we push this, then we go to this guy and we're like, that's smaller, okay, and finally we push ourselves. And then I go to this guy And why did I pop him, bruh? This is weird. Like that. That's the whole code. You have to be kidding. Damn. Okay. Okay, I was overcomplicating it. Whatever. Simple stack. Each person can see people to the right with increasing heights up to and including first person with a height larger than his height. Let's keep this increasing sequence on a stack. When we encounter a new street, can be paired with those. But I wonder why, because important observation is that people to the left of the current person cannot see the people, a new person I with height that left of the person I cannot see the people that people to the left of person I cannot see the people smaller than a person I to the people to the right of I that are smaller on the stack that are smaller than H. Since okay, so what have I written even? How to update the stack when we encounter new person I with height H. He can only see the smaller people on the smaller people on the stack and the first taller person. Important observation is that people to the left of the person I therefore we pop all smaller people than H on the stack and add their count to answer I. Finally, if there is still a pet in the stack and his height is larger, we increase answer I by 1 since person I can also see him, but people I minus people to the left of I can also potentially see him, so we people to the I taller than H can see him, so we do not pop him from the stack. Finally, we can add I to stack. O of n, since each element is removed from the stack, is added and removed at most once from the stack, and we do O1 extra work for each person. O of n, since we store at most all elements in the stack at each time. Okay, I kind of thought too much, but I had the idea, so maybe next time I will get it. Goodbye.